The programmer's wife tells him, "Run to the store and pick up a loaf of bread. If they have eggs, get a dozen." He comes home with 12 loaves of bread. Now you're probably going, wait a second. The reason I bring that up is if they have eggs, get a dozen. That is a conditional statement. And conditional statements are used a lot in logic and in programming. We won't be doing any programming today. And if you want me to, I can explain that joke later. So, looking at if-then statements. Well, a conditional statement can be written in one of three forms. It can be if something, then something else. Or you can say if this, and you can leave the word then off. If they have eggs, get a dozen. You don't even have to say the then. You can say get a dozen if they have eggs. If they have eggs, that implies you will get a dozen. If get a dozen only if they have eggs. So, anyways, there are different symbols. The easiest one to look at, P stands for the hypothesis, the part that's after if. Q stands for the conclusion, which is usually after the word then. So we can draw it as P with an arrow to Q. Sometimes you'll see a Venn diagram where P is in the inside and Q is on the outside. And my students delight in this when I say a conditional statement is true if the hypothesis is true and then the conclusion is true. So if I can make it so that if I'm standing in P, then I have to be in Q. So the hypothesis is the part P of a conditional statement following the word if. And the conclusion is the part Q of a conditional statement following the word then. Sometimes the word then is understood rather than written. So here's an example. I'm going to underline the hypothesis and circle the conclusion for each conditional. First of all, I'm going to look for the word if. Now, you could have conditional statements that you don't normally see them without the word if, but normally most of our conditional statements will have the word if. Whatever follows that word if is your hypothesis. So there's my hypothesis. And then the rest of it is the conclusion. You don't normally include the then in that. The if and then are two separate pieces. On this one, if is at the beginning, so my hypothesis is at the beginning. And here's the then, my conclusion is after the then. So now I'm going to write a conditional statement for this picture. Remember we're looking at the beginning we had that Venn diagram, and the hypothesis is in the center, and so if it is a blue jay, and I put it in, I just added it in. So I'm looking for a statement to say something about blue jays. So I'll say, if it is a blue jay, then the conclusion is it must be a bird. So in this example, with this, whatever's in the inside of the Venn diagram is the if part, and the outside of the Venn diagram is the conclusion part. Now, to find the truth value, see if you can make the hypothesis true and the conclusion false at the same time. If you can, it is false. But if you're not able to do that, if you can't make the hypothesis true and the conclusion false, then you have to assume that the statement is true, which might feel a little confusing. So, for example, if a line is perpendicular to a segment, then it is the perpendicular bisector of the segment. So I want to make this hypothesis true. I'm only going to look at instances where this is true. So a line is perpendicular to a segment. Well, there's a picture with a line perpendicular to a segment. And it does happen to be the perpendicular bisector. But is that the only way I could have the line perpendicular? No, I could have it perpendicular on the edge of the segment. And in that case, it is not the perpendicular bisector, so it is false. So statement is only true. If a statement is only true sometimes, then it is false. It has to be true all of the time to be true. So for further reflection, what do P and Q represent? And if the word then does not appear in the conditional statement, how can you tell which part is the conclusion?